Hello friends, our today's topic is fitting of binomial distribution. We already have seen binomial distribution, and the binomial distribution, the probability of the same is NCR P raised to R Q raised to N minus R. Okay, if we have given some statistical data like the values of x and its frequencies are given to you, like we have x and f of x, a table where there are some values of x like x1, x2, x1, xn, and there are some values of functions like f of x1, f of x2, and so on. And then this statistical data, they ask you to find or fit a binomial distribution to it. That is, we have to fit this formula and we have to find the frequencies by that. Then if such table is given to you, we know how to find out its mean if the values are given and corresponding frequencies are given. So then mean is defined as mean is summation fx upon summation f. This is the mean. But in case of binomial distribution, mean is, we have already seen in my last lecture, the mean is n into p. So it is np is summation fx upon summation f. And in your example there is also given n. So write that n and try to find out p by using that. Okay, we'll take one example so that you can understand. Four coins were tossed 160 times and following results were obtained. Number of hits and frequencies are given. This is x, this is f. The values are 0, 1, 2, 3 and 4, and the frequencies are 17, 52, 54, 31 and 6. And the question is fit a binomial distribution okay. Here we have to first find out your value of n. So can you tell me n here? N is 4 coins were tossed 160 times. This is just a frequency. So how many coins were tossed? There are 4. Or we can also see from this, if we are considering it as successes, so there can be 0 successes and there can be at most 4 successes. So it is 4 coins, or we can say this highest number, that is, this is the value of n. So n is here 4. And then we have to write the formula, that is mean. And the mean is nothing but summation fx upon summation f. So we are finding that we are fitting binomial distribution. So binomial distribution, for that mean is np. So np is equal to, we are writing summation f into x, that is 17 into 0 plus 52 into 1 plus 54 into 2 plus 31 into 3 plus 6 into 4 upon summation f, that is 17 plus 52 plus 54, 31 and 6. And but we know n also, n is 4. So 4p is equal to, if we'll add them, we'll get 277 upon 160. So from this we can find our p, and our p is 0.4328. This is your p. If you have p, we can also find out q. So q is 1 minus p. we know that, and Q is then 1 minus 0.4328, and therefore Q is 0.5672. We have P, we have Q, we have N also, and we need formula by binomial distribution. Formula is probability of R is NCR P raised to R Q raised to N minus R. Next we have N, we have P, we have Q, we just need R, and the R now are the given values of X 0, 1, 2, 3 and 4. These are your R. So for different X there are different R, and we'll find the probabilities for that different X. So we'll first consider R is 0. So probability of 0 is equal to 4, N is 4, 4C0 P raised to 0.4328 raised to R, R is 0 into Q 0.5672 raised to N minus R, 4 minus 0, that is 4, and which is equal to, we can find it, 0.1035. Find out this value, we'll get it. Next, probability of 1, 4C1 P raised to 1 into Q raised to N minus 1, 4 minus 1, that is 3, and we'll get 0.3159. Next is probability of 2, 4C2 P raised to R Q raised to N minus R, 4 minus 2, 2, and we'll get the answer 0.3615. Next, probability of 3. Similar way, we'll find also probability of 3. 4 minus 3, 1, and that is 0.1839. Next, probability of 4, 4C4 4328 raised to 4, 0.5672 raised to 4 minus 4, 0, that is 0.035. Okay, these are all the required probabilities, and then we have to find the frequencies. So if we have probabilities and then we know the formula for frequency, if you have the total frequency of an experiment and we have probabilities associated to them, then frequency is defined as, in case of probability, it is probability of R into summation F. Remember this formula. These are called expected frequencies. By that fitting of whatever we want. We want a binomial distribution, so we have to find out the probabilities by that distribution only, binomial, and then we are interested in the frequencies. So now we'll find frequency of 0. First we have to find probability of 0 and the corresponding frequencies we are finding. So frequency at 0 can be defined as, by this formula, probability of 0 into summation F. And we know the summation F is, this is all the values of F, and we have already find out summation F. Summation F is 160. So summation F is 160 and probability of 0 is 0.1035 into 160, and the value is 16.56, and approximating this value will get 17. As it is frequency, we need to approximate. Secondly, frequency of 1, that is probability of 1 into summation F, that is 0.3159 into 160, and we get 50.544. And approximate, we can approximate it to 50 also or 51 also, as it is 5. Next it is f of 2. Probability of 2 into summation f, it is probability of 2 is 0.3615 into 160. We get 57.867 and we are approximating it to 58. Next f of 3. Probability of 3 into summation f, that is 0.1839 into 160, that is equal to 29.424 and will approximate it to 29. Next f of 4 is probability of 4 into summation f, that is equal to 0.035 into 160 and that is nothing but 5.628 and we will approximate it to 6. Okay, and remember, whenever we are approximating these values and if we'll add them all, it must be the total frequency, that is summation f, and summation f was 160, so this summation should also be 160. So just check, is it 160? As it is not 160, it is 161, so approximating is wrong somewhere, so we'll go back and check wherever it is wrong. So it should approximate to 50. Now we can check. This is exactly 160, so this is your answer, and we'll tabulate it finally as, therefore tabulating, get R and F. So different R are 0, 1, 2, 3 and 4. We let our X as our R and its corresponding frequencies are 17, 50, 58, 29 and 6. And this is your answer. This is the required fitting of binomial distribution. We'll take one more example. Fit a binomial distribution to the following data. This is X, this is F, frequencies. X are 0, 1, 2, 3, 4, 5 and 6. And F are 6, 20, 21, 12, 8, 6 and 0. Okay, this is your data given to you. Then we have to write the formula. Formula is mean is nothing but summation f x upon summation f. We'll try to find it, but we have to solve it by binomial. So in binomial, mean is NP. NP is equal to summation fx we'll find, and it is 174. We can check. And summation f we have to find, which is equal to 80. And n here is 6. So 6p is equal to this 174 upon 80. So finding p will get 0.3625. Similarly, we'll get q also. Q is 1 minus p, which is equal to 0.6375. Okay, we have pq, and then we can write by binomial distribution. Probability of R is NCR, p raised to r, q raised to n minus r, where n is 6 and p we have, q we have, and r are these different values of x. So we will first find probability of 0. This 4c 0, 0.3625 raised to 0 into 0.6375 raised to n is now 6 raised to 6 minus 0, that is 6, and the answer is then 0.6712. Next, second probability of 1, which is 6c1, p raised to 0.3625 raised to 1 into q raised to 0.6375 raised to 6 minus 1, that is 5, and that is equal to 0.229. Then probability of 2, 6c2, p raised to r is 2, and q raised to n minus r, 6 minus 2, 4, and its answer will be 0.3255. Next, probability of 3, in similar way we will find it. And the answer is 0.2468. Then probability of 4, 3625 raised to 4, 0.6375 raised to 6 minus 4, that is 2, and it is equal to 0.1052. Next, probability of 5, 6c5, 0.3625 raised to 5, 0.6375 raised to 6 minus 5, that is 1, and we'll get it as 0.0239. And last, probability of 6 is 6c6, and its answer will be 2.269 into 10 raised to minus 3. Okay, these are the probabilities. Now we have to find out their frequencies. So we have the formula: frequency is equal to probability of r into summation f. So we'll find now the expected frequencies by binomial distribution. So we'll first find frequency at 0. It is probability at 0 into summation f. So probability at 0 is 0.6712 into summation f is 80, and this answer is 5.36. Approximate it is 5. Next, frequency of 1, probability 1 into summation f, that is 0.229 into 80, which is equal to 18.32, that is 18. Next, frequency of 2, that is probability of 2, which is nothing but 0.3255 into 80, and we get 26.04, that is 26. Next, frequency of 3, that is probability of 3 into 80, and which is nothing but 19.744, that is equal to 20. Next, it is frequency of 4, that is probability of 4, 0.10, 1052 into 80, which is equal to 8.416, that is equal to, we'll wait, where is to approximate that. Okay, I'll approximate to 8. Then f of 5, probability of 5, 0.0239 into 80, which is equal to 1.912, which is 8. And next is frequency of 6, which is 2.269 into 10 raised to minus 3 into 80, that is equal to, that is equal to 0.18, and which will be approximate to 0. So kindly check, is this value equal to 80? If it is not 80, then our approximation is wrong somewhere. Then our approximation is wrong and we have to correct it. I think it is not 80, then we'll approximate it somewhere. We have to approximate, it is 79. So we have to, here we'll approximate as 9. Right? So we'll get now 80. Therefore, finalizing this, tabulate, we'll get the answer as R and F. So different R are 0, 1, 2, 3, 4, 5 and 6. And the frequencies are 5, 18, 26, 29, 2 and 0. And we can check, after applying binomial distribution, the frequencies will change. Okay. This is your binomial distribution fitting. Hope you understand. Thank you.